So yeah, I'm Pierrick Bruneau, and thank you for the introduction. And I'm going to focus mostly on transfer learning and usage of mixed input for, especially for the multimodal flood level estimation. So yeah, we focused as I understood some of the other teams. We focused made on the two first subtasks, the summarized here as an NITD and MFLE. We chose deliberately to not use specialized models for example, pose estimation. It will be interesting to see how other teams use open pose, this kind of tool. But we really chose to be agnostic with this respect and see how, to which extent, deep neural network model were able to extract relevant features for the task without any prior knowledge. So in the end, we considered standard binary classification problems, and we focused mostly on evaluating the value of transfer learning. So in our submission, we considered transfer learning as some external information, and also for the multimodal task, evaluate the value of a dual branch model, where with one branch the image modality and another branch with the text modality. So kind of different with Siamese networks you may find in literature, for example, for automatic caption. Here the focus is to get the final class instead of learning some kind of similarity. So overall protocol, we train all models for 50 epochs with the Adam optimizer. With the learning rate, the standard learning rate, except for fine-tuning, for model fine-tuning in the case of transfer learning. So we use the F1 on the positive class as validation metric, in any case it's the task metric in the end. Among epochs, we selected a model with the best validation metrics. We used batches size of 32, so to get some balance with on the deep learning scale, the fairly small data set, and at least get some chance to have at least one positive instance per batch. We use stratified 5-fold cross-validation, and due to the imbalance and somehow small data set, we chose to build model ensembles as obtained in each cross-validation fold. And we use instant weighting to balance class importance. We also tried out SMOTE for undersampling the majority class and oversampling the minority class using data augmentation, but it's in gray because it didn't give any conclusive results. It didn't do better as regular instance weighting. So for the text, we tried several architectures, took some fair time on that, tried LSTM, BLSTM, multi-head attention, and some others. And we evaluated with somehow related tasks, so news classification, IMDb, the polarity detection in movie reviews. And so in these cases are balanced, so it's easier. And actually no option gave significantly better result than the regularized LSTM randomly initialized, so we went for that. And the hypothesis is that the classification task at end is simple enough to not resort for sophisticated models. For example, the interest might be, for example, in machine translation. So for text, we also tried out some kind of data augmentation by trying a random offset to the fixed size text, because when you train, for example, in LSTM, you have to set a fixed text size that you extract by cropping the input text. And we tried to put a random offset in the original text and see if it gets better. And actually, it didn't get any better. So hypothesis is that the meaning, the first words carry a lot of meaning in use, and this makes sense somehow. So textual features, in the end, we use 50 words extracted from the text with a hidden vector size of 100. I'm going to speed up a bit. So that's about text. So for image features, we use the Inception V3 pre-trained with ImageNet, VGG16 pre-trained the reference version trained on PlacesNet. We thought that as its place recognition is somehow fit for that. And MobileNet V2 for random initialization, because you have less parameters in that. So classic resizing and augmentation techniques, and using of the fully connected layer as embedding. So for the mixed input, it's a combination of ConvNet and LSTM. We just added some fully connected layer reduction for the ConvNet because on one hand you have 100 dimension, on the other more than 1000. So we put some reduction so that to balance the influence of both modalities, and then it's just a regular classification network. So in the end, so that's the raw results. And then the takeaway, the fine-tuned VGG16 is the best for an ATD in the end. And quite surprisingly, the LSTM with Inception V3 is best for MFLE, where somehow it was trained on ImageNet, so it's kind of surprising. It's not specialized for scene recognition. In the end, the random initialization with MobileNet V2 performed surprisingly well. Starting from random initialization, no pre-training, it scores in between Inception V3 and VGG16. There's a small positive text plus image combination effect for the flood level estimation task. Maybe for future work, trying some outlier detection method instead of going for pose detection, because here it's 3% of positive class, so it's highly imbalanced. We are at the level of outlier detection. So just a bit of insight with true positive, false positive, and false negative. So we're showing here some class activation maps. So we see that quite often for the true positive and the false positive, it's patterns in the water that gets that are triggered for the classification, that are somehow selected as important for both tasks. And for the false negatives, so apparently this was positive in the INATD task. I guess it's related to the article is related to the flood, but it's the image of some politician speaking, and somehow the microphone, I guess it triggers the negative class, so it gets here. And here is the pile of junk in the foreground that is somehow triggers the negative class, whereas in the background there's a boat and water. So just to get a bit of understanding about what happened. So that's mostly it. I've finished. So thank you. If you have any questions.